Today, this video for you is about properties of trapezoids, where they have one pair of parallel sides. Reminder, we're going to reason abstractly and quantitatively. We're going to construct viable arguments, and in this video, we're going to really critique the reasoning of others. A trapezoid is a quadrilateral with at least one pair of parallel sides, and when a trapezoid has exactly one pair of parallel sides, the parallel sides are the bases. And its non-parallel sides are the legs. So a little specificity. Bases and legs of a trapezoid. The base angles of a trapezoid are either pair of angles, so either on the top or the bottom, that share a base as a common side. So maybe if we define this trapezoid where this is the base, but this is also the base, but we're really going to focus on angle T and angle R for page 410 video. You can prove that the base angles of an isosceles trapezoid are congruent, given we have an isosceles trapezoid. So something we should know about isosceles trapezoids are, let's add this detail here. This side, RA, is congruent to this side, PT. The bases of PA and TR are parallel, and that's about it. Because in our lesson right now, in this video right now, we're talking about how we can show the base angles are congruent. It was kind of stated as a fact earlier on in our geometry, but now it's like it really needs to be clarified through proof. Let's do the two-column proof for what's here. Now, we always start with the given. So when the given statement is provided, we need to put that first. And so all of that is going to go first. And then if you notice the prove statement, so prove that angle T and angle R, those are the base angles. Prove that they're congruent. This is a random isosceles trapezoid. So if you prove that this random isosceles trapezoid's base angles are congruent, then it must be true for all isosceles trapezoids. We're going to make sure that we identify the last statement is the thing that we're supposed to prove. And everything in the middle, well, that's the recipe we got to create. We got to create the recipe so we can actually solve this. We can actually prove that what we have is true. Let's go to the next statement that's there. We have ZP is congruent to RA, and we just do that through construction. There's a way to copy an angle, and so I guess if we copy an angle, we can prove that those two angles are congruent because they're actually corresponding angles. We might use that. In fact, I think I see corresponding happening right down at step 9, but okay. So anyway, step 2 is all about constructing. Just make it. Step 3, that creates a quadrilateral ZRAP, and it's a parallelogram. It's a parallelogram because when we created ZP parallel to RA, this creates parallel markers. And so in this little shape, you have a parallelogram because the opposite sides are parallel. So definition of parallelogram, two pairs of parallel sides. Statement 4, ZP is congruent to RA. So we need to add some markers there. Let's go ZP, put a spike on it. And RA already has a spike on it because it's an isosceles trapezoid. So that tells us then that if it's a parallelogram, opposite sides are congruent. That's what's happening right here. We have opposite sides of a parallelogram are congruent. That's our reason. See, boom, boom, there it is. TP and ZP are congruent because of the transitive property. Like right up here, TP and RA are congruent, and then ZP and RA are congruent. So if we think about what you've done in your Matheo work, then you're really bringing this one and this box together to make one box. They like using transitive property. That is the better property to use here. But maybe in all of your Matheo practice, you used substitution. That would equivalently work. But because of congruence, trapezoid is better. Or not trapezoid, transitive property is better. This triangle. Step 6. Step 6, this triangle. It's isosceles. Two sides are the same. In an isosceles trapezoid, triangle. In an isosceles triangle, two sides are the same. And so that also tells us that angle T and angle TZP are going to be congruent. And so I've got those markers right there. Angle T and angle TZP. They're the base angles of an isosceles triangle. So in the isosceles triangle theorem, base angles are congruent. That means that angle TZP and angle R are congruent by the corresponding angle theorem, which I don't know why that had to show up in angle 8. I would have put that even way earlier, certainly before the triangles. But it happened now. It happened eventually. So there you have it. And then last of all, right, we have angle T is congruent to angle TZP. And we have angle TZP is congruent to angle R. And those two statements, arrow and arrow, point to the last one through our friend, the brother of substitution, the sibling to substitution, transitive property. Again, because we're dealing with congruence and not equality, transitive property is the better one to use. Substitution should be pretty much saved for when you have equality, okay? Substitution property of equality. But there you have it. That is it. Those are two base angles, and through this 9-step process, we have shown that they are actually congruent. We used parallelogram and isosceles triangle glued together through a composition, and that created our proof along the way. We get to now use this as a fact. It has been proven, so as a fact, we get to say base angles of an isosceles trapezoid are going to be congruent, just like base angles of an isosceles triangle are congruent. Page 411 is next. Stick around for that video. Click forward on this one. Thank you for watching. Like, comment, and subscribe, and we'll see you later on in your geometry journey. Thanks. Bye.